Welcome back to Math 103. This is video number 18 on apportionment. To find the Webster apportionment of 38 seats to these 6 states based on their state populations, we always start with the standard quotas and ask if they will already do the job. That is, we round each one to the nearest integer and see if those add up to the correct number of seats, and alas, they do not. They add up to 37, and that's slightly bad news. But not terribly bad news. It just means that we're going to need a modified divisor. So should the modified divisor be greater than or less than the standard divisor? Well, we've produced not enough cookies. We need, therefore, a smaller cookie cutter to produce slightly more cookies. In other words, we need a lower modified divisor. So we need to nudge the standard quotas higher, so that after rounding they sum to 38. Knowing, therefore, that our modified divisor has to be less than the standard divisor, our hint boils down to asking us to choose among these 3 candidates for modified divisor. The hint also contained a few candidates that were greater than the standard divisor. We can now throw those out. We can cross them off the list. So our hint boils down to picking one of these 3. After some trial and error, in practice not too much trial and error, it turns out that of the modified divisors on that list, 446,000 does actually work. The others, it turns out, don't. But this one does work. So that means that we have, how did we find out that it worked? It means that we computed state population divided by modified divisor and computed how much that equals for each state. And after rounding each one to the nearest integer, it turns out that this sum of rounded modified quotas really does happen to equal 38. So that's what it means that 446,000 works as a modified divisor. All right, so this is, each one of these is state population divided by modified divisor. Now, it's worth noting that this is exactly the same apportionment of the 38 seats that Hamilton came up with. Different apportionment methods can produce the same apportionment, and they often do. But they can also produce different apportionments, as we've seen, and we're never surprised when that happens. This concludes our discussion of Webster's method, and we go on next to the Huntington-Hill method, the method that's actually currently used to apportion the U.S. Congress.